Hello, my name is Jeremy Rigneris, and welcome to the Choose SolidWorks Screencast series. If you design assemblies containing thousands of parts, it can at times be frustrating as you're often limited by the resources available on your computer. Luckily, SolidWorks can automatically make the most of valuable computing power and memory to work with large assemblies, create drawings, and share complex intellectual property securely. No other CAD solution offers the power and flexibility of SolidWorks. Massive assemblies? No sweat. Let's start by establishing a baseline for how traditional CAD tools open these large assemblies. This design from the Vermeer Manufacturing Company is detailed right down to the last nut and bolt to ensure correct clearances, center of gravity, and bill of materials. This file was opened fully resolved, in which all the files are loaded into memory, typical of many design tools available today. This video was sped up, but it takes about a minute and a half to open and a little over 2 gigs of total memory to open this assembly in SolidWorks fully resolved. With nearly 6,500 components, it's a medium-sized assembly, but even so, if you don't have the available computing power, you're going to struggle. If you take a look at the level of detail in this assembly, some parts are simple, like the fasteners, and some are complex. But the important thing is that it's complete, so there's no possibility for error during manufacturing. So how does SolidWorks make this process any easier? You can set a default threshold for SolidWorks to detect the number of components in an assembly and activate large assembly mode, which enables some performance-enhancing settings. SolidWorks also provides convenient ways to access your data. When trying to find your top-level design, it can often be difficult when working with thousands of files. SolidWorks answers this with a simple one-click button from the Open dialog box to filter out top-level designs. The exact same assembly will now be opened using the settings that were shown a moment ago, automatically enabling large assembly mode. This time, however, it only takes about 19 seconds to open and only consumes 921 megs, less than half the memory used previously. This means you can make more use of the available resources on your computer. Other performance-intensive features are disabled, such as reflective surfaces and shadows. Rotating the assembly, complex geometry is temporarily simplified as well, reducing graphical overhead. The most significant change, however, is all the components are loaded lightweight, noted by the feathers in the assembly structure. Lightweight components contain all the solid geometry, but none of the underlying feature detail, reducing the resources required. Working with lightweight components is seamless, as you can still make crucial design changes, and only the information needed is loaded, on demand. Because all the solid geometry is available, you can still perform important validations as well, such as checking for interferences and assembly motion, all while working in your top-level assembly, ensuring nothing is missed. But what about creating drawings of large assemblies? Because the geometry of all the parts is available, making the drawing is easy. However, SolidWorks does use some clever tricks invisible to the user to speed things up. SolidWorks leverages any available cores in your computer when creating drawing views, and you can see how quick it is to lay down 4 views of the 6,500 component assembly. Moving around the drawing is also quick, as SolidWorks uses image refinement technology to reduce the amount of data on screen at any one time. This means you're never waiting to start working on your drawing. Like the assembly, even though you're using lightweight components, none of the information is missing, meaning you can add dimensions as needed. SolidWorks even provides useful tools for locating dimensions while zoomed in on large, complex designs. Bill of materials are also crucial, and SolidWorks doesn't hesitate here either, quickly gathering information about the assembly's components. The only thing you have to decide is where you'd like to place it. SolidWorks takes care of all the hard work. SolidWorks provides several other tools for simplifying and working with limited subsets of components. Opening the engine assembly of this horizontal grinder provides an opportunity to show how several of these tools work. Configurations, for example, provide an excellent way to simplify or limit what you would like to work on. Configurations are typically used to create variations of a design, but they can also be used to simplify components and assemblies, or create subsets of designs that can be opened directly. When you need to focus on a specific design task or on a subset of parts in an assembly, you can select just the parts you would like to work on and choose to isolate those parts for a more focused workflow. SOLIDWORKS can even save these display characteristics as a unique display state. Display states capture the visual properties of parts, allowing you to return to this subset of components at any time. Sharing complex designs with lots of unnecessary detail or designs containing sensitive intellectual property is not a problem with SOLIDWORKS either. Using a technology called SpeedPack enables you to reduce the amount of data in a design by interactively choosing which faces or bodies to include. SpeedPack determines which components are internal to the design and then with a slider removes faces or components based on their size. You can alternatively selectively choose which faces to retain, such as those interfacing with a top-level assembly. Likewise, you can choose entire parts or bodies as well. Once the SpeedPack configuration has been created, it doesn't really look any different. That is, until you move your mouse over the assembly. Only the faces and bodies that were interactively selected physically exist in the model. The rest of the geometry is only available graphically. This both protects intellectual property and reduces file size and performance usage significantly. Returning to the top-level assembly from before, which this engine exists in, you'll notice an option in the open dialog that utilizes this SpeedPack technology. SOLIDWORKS checks each sub-assembly and determines if it contains a SpeedPack configuration. This further reduces open times and memory usage to an even greater extent than before. Loading in just 9 seconds and using only 692 megs, it's a fraction of the original fully resolved assembly. Like the engine design, only the selectively chosen data is loaded. If design changes have taken place, those assemblies will be noted in the assembly tree, and all that's required is to choose to update the SpeedPack. This means you never lose anything due to revisions or design changes. SOLIDWORKS does not switch flexible subassemblies to SpeedPacks to retain any relevant motion in the top level. However, like the update, you can decide to switch it to its SpeedPack configuration, further reducing overhead, but the motion will be fixed. So how does this graphical geometry affect drawing creation? View creation is identical to the process used before. This time, all 4 views will be placed at once. The drawing makes you aware of which geometry was created in SpeedPack by changing its color, but this has no effect on any final printing. Likewise, any geometry that's been included in SpeedPack assemblies can be detailed just as before. Drawings are fast and responsive due to the limited use of solid geometry, leveraging graphical data instead. As you can see, SOLIDWORKS can tackle any assembly from the smallest to the largest. Massive assemblies, no sweat. Thank you for taking this quick look at how SOLIDWORKS handles large assemblies. We strive to deliver simple but effective tools to help you focus on creating fantastic designs, not fighting a CAD system, and to make it an enjoyable experience too. For more information and to see other screencasts in this series, please explore the SOLIDWORKS website or contact your local SOLIDWORKS reseller. My name is Jeremy Rigneris. Thank you for watching.